topic is data science. Now, don't think that data science is a computer science department subject or a computer science department company, and IoT is an electronics communication company. These are all always interlaced. I'll tell you how data science works is with respect to IoT, right? For example, let's take the same IoT, right? There is a data discovery. You collect some bunch of data. It is prepared inside the system, right, in a proper rows, columns, classifications, syntaxes, conditions, etc., etc. There are models that are built through which these data are passed, right? That's where your interface comes, right? For example, the intensity of, let's say, a bright light, brightness of light, or let's say the temperature at which the cooker should cook, or the speed at which the washing machine should operate, etc., etc. So you build models where these data go through and they give you a meaningful information, which is then communicated with you, and you control the device based on whatever data is generated. So this is how data science cycle looks like. So data science can be generally applied elsewhere also. That application also we'll discuss, but also we'll discuss with specific to IoT how it has application. For example, right, again, if you understand what are the top skills that are required, right, for with respect to data science, Python and R are the very clear winners. SQL is something different, and you have something called a SAP as well. Okay, you have big data tools like Spark, Hadoop, etc., etc. There are different tools, guys, basically. But R Python has been predominantly used. Okay, everything has its advantage and disadvantage. That's a different ball game. Okay, but R and Python has been predominantly used. So if you understand the skills that are required for you to become a data scientist, either in the IoT domain or generally, one, you must understand core statistics. Your mathematical modeling should be very, very strong. R and Python depends upon which kind of niche you want to get into, right? Machine learning algorithms, right? Data visualization tools, like you have tools like Tableau, you have tools like Google Studio, you have different tools like Power BI, etc. And you need to understand a little bit of databases, AWS, little bit programming touch bases there, and basic communication business skills. So these are the fundamental skills, the soft skills and the hard skills that are required. Similarly, right, you understand in terms of statistics, what are the skills that you should acquire? One, there is in descriptive statistics. Second one is in inferential statistics. Descriptive statistics is like, let's take a height as a concept. Now, what is descriptive is that you classify some people under maximum height, some people under average height, some people under minimum height. What is inferential is that you, based on the height, you're able to tell him whether he's tall, average, or short. So that's the difference between descriptive and inferential. So these are fundamental skills you need to learn. So when you take this framework, right, you apply this across any data point, you will still be able to understand what is the difference between descriptive and inferential. Okay, these are fundamental skills. Similarly, right, you take the difference between R and Python. Now, what is the difference, right? R is more of a statistical language, whereas Python is used for a general. What do you mean by that is, R is most probably used in the computational state, for example, for descriptive purposes, etc. Whereas Python is also used for that and for other purposes. So Python has a little bit edge on the same. And most importantly, right, R is always about better data visualization. Why? Because when you feed the data, R typically comes in the later stage of the data cycle. Remember this data cycle we saw, right? Hey, you know what? I'm building models. I'm getting into actions and communication. So R is a very strong application area in this particular area, in more of the visualization parts and the computation parts. Whereas Python is typically used in the deep learning side of it. So it takes a little bit in the earlier stage. For example, you prepare and clean the data, you build the mathematical models. So of course, everything has an end-to-end application, but the strength of a particular language lies in certain areas. See, when you become a data scientist, right, it's not that you're going to do everything. You'll always be only the data discovery stage. You might only be in the preparation stage, or you might just build models, or you might be the guy who's communicating to the client. So as per that, you kind of learn the skills that is required for you. Okay, and most importantly, right, you understand capabilities. It has different packages, right? Whereas Python is more of open source, so it is still kind of evolving there. R is more of a embedded in a programming language. Everything was given there basically, and generally the function is that R is a little bit slower when it comes to performing huge computations. Python is very, very faster, and in terms of popularity, R is less used and Python is more used. Okay, and again, if you understand that there are different clustering algorithms, okay, for machine learning, right, these algorithms are very, very important for you to learn. Okay, for example, when you pick up data science, especially in IoT, right, you need to understand these techniques. That's why I told you, right, you are not an electronics communication engineer. Please stop tagging yourself like that. You require certain skills that are required for the job. Please focus on that. Don't have this department things. I belong to a department. Show me AAA company. Don't ask questions like that. So the point is, right, there are different points, different algorithms that are used. For example, the K-means clustering, one of the famous ones that are used, naive Bayes, etc., etc. So these are different algorithm techniques And again, guys, whenever you show this, right, please don't come and tell me I have a 6 semester paper mark sheet on this. I have an online course certificate. No. Have you used K-means clustering in one of the projects? As an outcome of that, were you able to show that project has actual application in the industry? Actual application in the industry has created a small impact in the industry. Are you able to show all these things? Okay. Again, if you look at all these techniques, right, you cannot master all the techniques. Techniques are always classified based on supervised, unsupervised, supervised, unsupervised, and the reinforcement learning. So certain kind of techniques, right, come under the unsupervised learning, where the techniques run by itself, it's independent, etc. So the details and all we look into it later, right? And again, if you look at it, right, in terms of visualization, as I already mentioned, right, R is a language which is very, very strong in terms of the data visualization. Whereas Python, right, you have syntax, you have libraries what you can use for basically for visualization. So you feed the data, you use this particular library, the output gets generated automatically. You can kind of generate it using an IP address or something. Whereas R has its inbuilt data visualization tool, right? So for example, it can be I've used R extensively. I specialize in my analytics and MBA, right? So let's say I use some of the functions like lattice or a leaflet or a color burst or sunburst, something like that, right? I feed the data, the output will come here. You can download as a GIF and put it on a presentation. That's simple, guys. Whereas Python is a little bit more complicated. Getting it embedded on communication part becomes a little bit trouble, right? So that's a point, guys. See, the other point is that, right, and let's actually understand a case study. I've been talking a little bit theoretical in terms of the skills required, etc. Let's actually understand a case study. This was one of my former students who basically studied with us, etc. He did his masters in Carnegie Mellon University. He's working at Microsoft in the US. So this guy did a very, very interesting project, and one of his colleagues are doing this project. What this project was? This case study was taken from that. Okay, so Microsoft wanted to determine how does a face-to-face interaction among the staff could boost an employment performance and save money. Okay. See, right now it's a lockdown. Everybody's at the house working from home. It's always a big trouble to coordinate meetings, etc. But companies are desperately wanting their employees. For example, IBM has leased millions of square feet of offices spaces in Bangalore. So companies desperately want people to come back to their office and work. So one very interesting project application in this particular domain was Microsoft developed a project. This was before lockdown, basically. They did this. So what they did was they wanted to kind of develop an algorithm. The output of the algorithm is it could boost an employee performance so that the company can save money. Because the employee do 10 work units in 1 hour, 20 work units in 1 hour. The 20 work unit is more efficient for the company, right? So what did it do was, it was kind of moving some 1,200 people from a 5-building block to a 4-building block. So these guys were there in a particular place. From a 5-building block, they were moved to a 4-building block. So they use different analytic techniques. For example, right, they used to have these cards. So I have this student used to tell me, even if I have to go to the restroom, I need to swipe a card. So if I have to go to the pantry, I need to swipe a card. If I need to go to, let's say, a meeting room, what meeting is this about? Whether I am a part of the meeting, everything is kind of embedded in their card, their RFID tag. So before you swipe in, right, every data is being captured in terms of what you're doing inside the company. Microsoft did this very interesting experiment without even the employees knowing it. Okay. The point is, right, the heavy data science applications are running behind the background in terms of how they collect the data, what duration they do it, etc. Very, very heavy analytics was used, very heavy techniques were used, data science techniques. Now, what is the output? They did all these things, right? They were able to save combined 100 man-hours per week across all the reallocated staff members. This estimated a total saving of 520,000 US dollars in a year of employee time. So what happens is, I'll tell you what Microsoft did by using this also. Okay, they kind of gave improved statistics to their managers. Hey, you know what? Over a period of week, you're wasting so much time in a meeting room. Therefore, you could have all these meetings in a Zoom call or in a Teams meeting itself. You don't essentially need to come and meet physically. So the manager is able to implement that and increase the efficiency. Likewise, this process was going on continuously. Okay, so if you look at this data science funnel, right, you'll understand this application in real time. Let me show you the funnel. 1 second, guys. This particular thing. If you understand this, right, so what is happening here is the Microsoft is collecting the data, they're preparing the data, they're building models are the same, they're giving the insights to the managers, and they're communicating, and they are implementing, and again the process of data has been collected to improve the process. So this is like an infinite loop. It keeps running until the process, until like infinitely all the employees work to very, very efficiently. But at least, right, just imagine this, by doing this, they were able to save 520,000 US dollars just for one building with 1,200 employees. Now, Microsoft have thousands and thousands of employees, very, very big office spaces. And just imagine if Microsoft could sell this technology to different companies like Apple, Oracle, IBM, Intel, etc., how much money is saved there? How much money goes into the challenge there? 520,000 US dollars, it's like 3.2 crores or 3 crores of Indian rupees is saved by just a small algorithm. But the complexity in the algorithm is very much. That's the reason data science are getting paid in such huge numbers, guys. Okay, so that's a question. That's a question that I really want to leave you open with. What is the question is, your college curriculum. Let's understand this. Your college curriculum is like an old telephone booth. I'm not even sure whether you guys have seen this telephone. Okay, well, I was a kid. I used to be in my dad's office, right, in business. So they used to have this phone dialing very, very strongly. Apart from calling, nothing you can do with that. You can receive calls, you can make calls. But today, you guys know what is the level of smartphone application. You guys know to use smartphone much better than me or any of my senior people, because you guys are glued to this all the time, and you guys know how much advanced it is. See, one thing in terms of a usage itself, you guys know how advanced it is. At the same time, much more than you have imagined of, right? Smartphones are very much advanced. But the problem is the industry has been running in such technologies. Your college books, your college 8 semester projects, the college exposure. I've been learning something in college like an old telephone booth. So that's a question. See, that is a question that you guys will face when you actually have to crack an interview in IoT or data science. Where do you have such exposure? How can I get a job in my core domain? What are the specific skills? See, whatever I've told you is a niche. That's not exactly as per the job domains. Okay, and most importantly, what do I need to do overall? That's a question which I want to leave you open with. How do I adapt yourself? How do you adapt yourself so that these changes and all the hands-on skill that you require, you can build it over a period of time? So what I'm going to